This is Biochemistry Unfolded, From Atoms to Algorithms, a weekly podcast on the topic of computational biochemistry and biophysics. Well, good afternoon, or whenever you're watching this. Welcome to the second episode of my Biochemistry Unfolded podcast, From Atoms to Algorithms. The purpose of this podcast, I'm going to be talking about a lot of key information in the science of biochemistry and molecular biology and computational biology, computational chemistry, AI. We will be talking about some AI as well. Today I'm actually going to be talking about some skills that are very important to graduate students and scientists and everyone in the field, because that's your communication skills and scientific presentations. And so if you're starting graduate school, a master's or a PhD program, at some point you'll be asked to do a scientific presentation. Our master's students do at least two of those. The first one is a literature talk on you'll be asked to read a paper or a publication and give a talk about the key points presented in that paper. You'll also, of course, give a thesis talk at the end of your research on your own research. So that literature paper is actually very important to give you the skills that you'll be using to present that work, right? So scientific presentations are very important. And if you're doing a literature talk, you're going to want to present about a paper in the literature. And so one example of that I have is here is a paper that we have published with several of our colleagues here at Tennessee Tech. Florence was the graduate student that worked with me on computational chemistry of this. And so we were studying the structural and metal ion effects on human topoisomerase II alpha inhibition by thiosemicarbozones. And so they found that the thiosemicarbozones with copper were actually particularly effective at inhibition. And so when you're reading a paper, obviously you're going to read the title first, you're going to read the abstract. That kind of tells you if the paper is going to be important to you. And then if that's important, then you'll read more information in that paper. You'll read the methods and the results and other things that go on. And then maybe you'll take a look at the references and see if there's anything else in the body of literature that has been cited, right? Now, one of the tools that we have today is artificial intelligence, right? AI, if you don't understand it, you're going to be well behind, right? Because it's here to stay. Now, if you watch the movie Spider-Man, remember what Spider-Man's grandfather told him. With great power comes great responsibility. And so we want to use AI responsibly. You don't want to let AI do all the work for you, but if it helps organize your thoughts, then it's going to be really good. So we have a tool called SciSpace, and so that's right now it's at typeset.io. That's the URL for it. If you go to Google and just search for SciSpace, you'll come up with it. You can log into it. They do have a paid option. I'm just using kind of the free option. What's cool about this is you can actually upload a PDF. So it says chat with PDF here. And then you can just drag your paper over here and then upload that particular PDF. And that brings the paper into the AI. And on the right side is the chat window, which you can ask it questions, right? You can, there's some questions here that they've, pre-posed questions You can also pose questions here, so you can ask it to generate a summary of the paper, and it kind of gives you some key bullet points and some things. And if you use this responsibly, these are some of the bullet points that you should be looking at in the paper as you read it, right? So obviously we're talking about thiosemicarbamazones and their metal chelating properties and how they are anti-leukemic properties. And we talk about some of the key aspects and some of the palladium versus platinum complexes. And then, we could go ahead and ask it more questions. We can ask it what the major results are. And so then it'll give me a couple more bullet points about those key results, right? So the results we talked about are the synthesis of thiosemicarbamazones, inhibition by topo2A, dose-dependent inhibition, ATP hydrolysis inhibition, DNA cleavage activity, etc., and other important things there, right? Then we can also ask it what the major conclusions are, right? And so it's kind of thinking right here. So here's again the major conclusions of the paper, right? And so it kind of gives you some things to think about as you're reading the paper. So then when you read it, you're going to want to go through it probably with a yellow marker and kind of highlight certain parts. And this kind of what the AI helps you to do is to help you to prevent, missing certain key areas and certain key topics from the paper. So that's real important. Then you can ask it additional questions, like, for example, what molecular modeling techniques were used in this paper? And so the AI will then hopefully tell me about the use of Mo and its docking, right? And so docking studies on copper-2 TSC complexes with the ATPase domain of topo2 alpha. We started with the PDBID, they give you that. They've got the force field parameters. We used Amber 10 EHT with Mo 2022. And so then we talk even about how we prepared structures and our scoring and refinement and our visualization. So you can even ask it specific questions about specific techniques or other things that you may have missed when you read, or if you want more information about some of those techniques. So SciSpace is a very useful thing. Again, you can purchase extra, you can get some extra pricing, or you can use this free, depending on your level of use of it. So it's very, very useful there. All right. Now, what I want to do is talk a little bit about delivering effective scientific presentations and seminars, right? So these are some tools and tips for effective scientific presentations. Now, one of the things you'll probably use Microsoft PowerPoint. Some people really miss the old days when, back in the 1930s and 40s, you remember scientists like Albert Einstein and Oppenheimer. They're in a room. They're probably all smoking cigars. They've got a chalkboard up at the front of the room, and they're just writing on the chalkboard. That's called a chalk talk, right? We don't even have chalkboards in our building here. Chalk doesn't get on very well with computers. We do have whiteboards. We could do a whiteboard talk. But I think most scientists will organize their thoughts in a scientific presentation using PowerPoint. And so we're going to focus on that. The first thing you want to do is probably find some appropriate templates. The template you use, you don't want to use something too distracting, because you're going to have a lot of details in your slides, and you don't want to, you're not giving a sales presentation. You're not trying to sell something. you want to convey scientific information. So the less distracting information in your slides, the better. The slide templates I'm using, I obtained from Tennessee Tech's marketing department. And so they're very simple slides with mostly a white background. They've got a, kind of logo in the background of our Tennessee Tech logo. We use purple and gold as our colors. But it's not overly distracting. So the message that I'm trying to convey is still kind of predominant there. So you may want to go to the university's marketing website. They probably have some templates you could use, or maybe your advisor or another faculty member has some templates that you can use from your university. And that'll make things very, very professional. So a couple of good presentation practices. Number one is to understand your audience and your audience's background. Now, graduate seminars often do have a mix of different expertise levels, especially depending on your department. If you're in a biochemistry, or I was in a medicinal chemistry department for graduate school, everyone was kind of in the same general field. It was a little more specialized, so a lot of the terminology we used, we all kind of knew certain things. Everyone knew what structures were and what different syntheses were and that sort of thing. But if you're in a more general department, like a general chemistry department, you're going to have organic chemists talking to biochemists and analytical chemists and maybe a radiochemist and other people, maybe more people with a general chemistry background. So you need to take that into account and make sure that the terminology you use is appropriate for that level of audience, right? You also want to try and select the right paper. Now, the paper you select, if you're doing a literature talk, you're going to select a paper probably relevant to your research, or something that is a good general paper that you will probably use later on in your thesis research. Doesn't have to be, could be paper of general interest, but you're going to want to select a good paper that's important for you. And make sure, of course, your advisor will approve it, and make sure you get that approved through the appropriate people that you're working with. Because you're going to have to master that content. And so you're going to ask you're going to ask yourself the following questions, and you're going to want to be able to answer these questions during your talk. You'll answer the questions of who did the research, what was done, why it was done, how it was done. So you need to clearly convey these questions to your audience and be able to discuss the objectives, the methodology, the results, as well as the broader implications of that research to the scientific community and the overall body of literature that's important. And so that's probably a big part of what you're going to be graded on if you're doing this for a grade, right? You also want to develop a very clear structure for your paper. It's important you're going to have initially a title slide. Then you're probably going to have 5 separate sections. You'll have an introduction where you'll provide the context, objectives, and relevance of the paper. Then you go into the methods. You're going to briefly explain any experimental and computational approaches that were used in that paper. And then you'll have your results, including visuals and tables as appropriate. You're going to highlight anything that's key part of the results. You'll then have a discussion section. Now, this is often the most misunderstood part of the paper, but it's often the most important, because instead of just presenting your results, you're going to want to discuss the implications and the limitations, as well as future directions where this research is going to lead to. So that's going to be very important in the presentation. And then, of course, you're going to conclude with a brief summary and connect the work to broader topics. So you'll probably have between 3 and 5 bullet points in a conclusion. You may also have a future research slide or a future work slide where you may have 3 or 4 different areas where you might do additional research to expand on what was discussed in this paper as well too. So that's important. You want to avoid overly cluttered diagrams and figures. Here's a figure from our paper on thiosemicarbozones. I quickly cut and pasted this in, and that may not be the best strategy because, again, we've got a lot going on in here. We've got 3 different A, B, and C. My figure caption, it's important to have a figure caption, but that text is probably too small to really be read. So you probably want to use a larger figure caption that's a little bit easier to read. The text here is, I screen captured this at 72 dpi. Probably should have actually went to the website and downloaded a higher resolution version of this figure. And I may actually would decide to break up A, B, and C into separate slides that are a little larger and easier to represent and easier to see, because this is kind of busy, right? You do want to make sure and cite everything that you put in here. And so any citations that you have should be put on the slide where you're presenting the information, and put those kind of in the lower left corner. Here's where you can use a smaller font, like I've used 12-point font in this case. It's also very important to make sure that every reference contains at least 4 pieces of information. You need an author. Now, if there's more than one author on the paper, it's appropriate to list the first author and use the words et al. After that, and that just indicates there are more than one author. The date. In this case, I put the year, 2019. I've bolded the date. The title is listed, so that's right after the author. And then the source is the journal title. The journal is actually abbreviated and put in italics. Chem Research Toxicology. That's the abbreviation the journal uses. So if you go to the journal's website, they'll kind of tell you what the abbreviation to use for the journal. Like JAMSOC is JAMSOC, Journal of the American Chemical Society. Part of that journal title should include volume and issue and page numbers as appropriate as well. So it's important to have at least these 4 things. Don't include just a URL. A plain URL by itself is not a citation. It's really common to say, oh, I'm just going to use this figure that's posted on the internet, and I'll put the URL just to avoid plagiarizing. But that's just a URL by itself. That tells me nothing about who authored that or where it came from, right? So if you find it on a website, you should put at least the author of that website and where that's published and when that was published if you can. So that's always important. Videos, you may want to use a video. Now, a caution about videos, you don't want your video to be too long, and you want to pay attention to how long your talk is. So if you've got 20 to 25 minutes in a presentation, your video should not be a 10-minute video. Your video should probably be limited to about 30 seconds, maybe a minute. In molecular dynamics, if we're presenting video information, we'll probably put a short video, maybe no longer than 2 minutes. And then instead of putting audio narrative, I'm going to narrate the video while I'm presenting. That just sounds a little bit better. That way you're not just kind of sitting there while people are watching the video. You're actually actively presenting the video for them, right? Now here I have embedded a video. And another thing, if you're going to embed a video, and download the video to your hard drive as an MP4 file or an MPEG. Don't just link to it, because on the day of your presentation, you may not have internet. It may be down. You might be in a location where there's no internet. So don't take those chances. Download the video so you can be prepared to present it without the internet, right? This video here that I've cited, this is another talk on YouTube. It's a TED Talk by David Phillips. It's How to Avoid Death by PowerPoint. He's got some important things that he talks about with PowerPoint presentations. It's a pretty good video. So I've provided a QR code over here so you can scan that QR code and you can watch his video if you want. Notice it's on YouTube. I've cited this just the same way I would cite anything else. So I've got an author, I've got a title, I've got a date. Now I've cited TED Talks as the source as opposed to YouTube, although I've provided the YouTube link here. So TED Talks, TED puts a lot of their content on YouTube. So yes, this is very important. So again, that author and title lends credibility to whatever it is that you're presenting about, right? So when we're presenting, we want to make sure and practice regularly, and it's important to rehearse multiple times. This ensures a smooth flow, and it helps you stay within your time limit. It also helps to practice with various peers, and they can even suggest several questions for you as well. You also want to engage your audience, and so you want to have a compelling introduction, kind of a hook that captures their attention and gets them to want to watch more, right? A lot of YouTubers talk about doing that in their YouTube videos as well too. So that's really important. Your first, minute is going to be the most important because your audience is going to be most captivated to want to hear more about what you're talking about. And it's important to maybe tell a story about the work. Pause to explain various critical concepts and methods, but keep telling, put your information in the story. It's less important to really tell everything, right? And you want to simplify and break the complex topics down into easy to digest bits of information. You want to avoid jargon and technical. I guess Star Trek refers to this as technobabble. If your talk is too technical, your audience is going to kind of lose interest, and they're going to be less interested in that. So you want to try and avoid all that technical jargon and that technobabble, right? Anticipate several questions, though. And this is where it kind of helps to practice, especially with your peers. What we used to do in graduate school is my friends would, say, I'm going to ask you a question about this, so you should be prepared to answer it. So we would have questions kind of loaded that helped us look a little bit smarter, right? And so prepare those in advance. They should be questions about different things, about the methods of the results, or even just about the broader implications of the work to the greater scientific literature. You want to, you could even find it useful to put an extra slide after your conclusion that you can jump to if somebody asks you a question that has additional information. So you'd put that after the conclusion. Maybe it's slide 36 and your conclusion is on slide 35. So, and then if somebody asks that question, you could just, and the way to jump to it is you can just on your keyboard in presentation mode, just press 36, enter, and PowerPoint will immediately go to slide 36. Oh, guess what? That reminds me, in my presentation, do you realize what I forgot? In these slides, I forgot slide numbers. It would help to put a slide number maybe in the lower right corner of this presentation, And that way, if somebody does have a question, they can say, I've got a question that's on slide 8. So you can hit 8, enter, and it'll take you to slide 8. They can ask their question. So don't forget to include slide numbers as well. Time management is something I often violate all the time. Yeah, no joke. My students constantly write in student evaluations for courses that he always goes over the allotted time. I'm working on that. I think I'm getting better. It's really easy to do. It's harder to do if you practice ahead of time. You kind of know where your time is, right? So that's always important. Nobody wants a talk that's going on for an hour and a half, and you're just kind of sitting there waiting for it to be over. You're watching your clock. You can even see some of the cues. If you're going a little bit too long, your advisor might be like, yeah, looking at your watch there. Like, yeah, it's getting too long. My Irish grandfather used to say, and I probably should quote this, if you can't be good, be brief, right? I think a lot of our literature talks may be 20 to 25 minutes, or we'll probably tell you, plan for a 20-minute talk and 5 minutes for question and answer. Or if it's a 40-minute talk and 5 minutes question and answer. Pay very attention to the amount of time that you have and don't go over, right? Ahead of time, probably the night before, I'll make sure and go into that classroom where you're going to be doing the presentation and familiarize yourself with the computer that's available, the projector, how to turn each one of them on, any other equipment, like if you're using a lapel microphone or anything else. Maybe you've got a camera that you're using. Maybe you're simulcasting on Zoom or Microsoft Teams. Make sure you're familiar with how to use everything in advance of your presentation so that you're not taken by surprise, right? Nobody wants to get to a seminar and you're supposed to start at 3:00 p.m. and you start at 3:15 because you spent 15 minutes trying to figure out how the computer works. And nobody can do that, and if I have to call the IT guy in. So make sure you understand that. It's important to speak clearly and confidently, making eye contact with your audience. You also want to use a microphone, maybe a lapel microphone if the room is particularly large. That might also help. So that's important. You also want to encourage some interaction. Pay attention to cues in your audience and don't hesitate to maybe post a question during your presentation to provoke additional thought. Get your audience thinking about stuff and maybe solicit some potential responses, right? Couple things to avoid. You don't want to use too much text. You also want to pay attention to font size. This presentation, the main bullet points I've used is a 28-point font, and then the minor bullet points, the insets, are 24-point fonts, so they're a little bit smaller. You also don't want to read your slides. Nobody likes you. The first presentation I did, I literally read my slides here, and I wasn't even looking at the audience. I was just reading. I'm not sure how that sounds or how that looks, but it looks kind of boring, doesn't it? They actually made me repeat that seminar. It was a literature seminar, and I repeated it, and of course I did much better the second time. So don't read your slides. That's kind of boring, right? And don't ignore your audience's background, right? If you're speaking to a general chemistry audience or a biochemistry or a biology audience or maybe geology, make sure you know what their background is so that you can avoid technical jargon in the methods of your paper, and you can tailor what you speak to either a more general audience or whoever you're speaking to. So if I'm giving a presentation, for example, to a group of cell biologists or molecular biologists, and I refer to a mouse, well, I'm a computational chemist. I know what a mouse is, but a cell biologist may think I'm talking about a small furry animal, right? So make sure you avoid using very technical terms. Of course, the mouse thing, I think we'll know what a mouse is, but that's a good example just as a fun thing. But anyway, tailor that content to your audience's background, right? Focusing too much on details. You don't need to present every little tiny detail of minutia in the paper. You want to focus on the key details. You want to focus on the main findings, the significance, anything that's supplementary that's important to understand your overall narrative or the story that you're trying to convey, right? So you want to focus on those key details right there, right? Don't get too focused on really tiny little details, right? And you want to avoid using poor visual aids. You want to make sure that your figures are large enough to be read. You don't want them to be overly cluttered. You also make sure you can scan things in at an appropriate size. Don't use very hard to read fonts. One thing about fonts, there's a difference between a serif and a sans serif font. A serif font refers to a font that has a little squiggly embellishment at the corners of the letters. That makes it looks cool, makes it harder to read, especially for someone with dyslexia or other learning disabilities. A sans serif font, sans meaning without, doesn't have those little embellishments. It's easier for someone with a learning disability to read a sans serif font such as Calibri or Arial than something like Times New Roman or Courier, right? So make sure you use a font that's clear. You want to avoid distracting colors. The text should be a high contrast between the text and the background. My mother is a quilter. She taught me about the color wheel. Go around in a circle, all the colors, Roy G. Biv, around the circle. Blue and yellow are on opposite sides of the color wheel. They're high contrast. Red and orange are not. So red text on an orange background, probably going to be hard to read. Blue text on a yellow background or vice versa would be much easier to read, right? I think it would be less distracting to put actually gold text or yellow text on a blue background. Sometimes that yellow as the background could be a little more distracting because it's very bright, right? So that's important. Also pay attention to accessibility. And accessibility does not just mean accommodating disabilities. Accessibility, and think in terms of universal accessibility, and making your slides as easy to read for as many people as possible. Two things you may want to look at for additional information are some principles on universal design for instruction and universal design for learning. If you go on Google and you look these up, you'll find a lot of really interesting topics and a lot of interesting strategies to making presentations as accessible and readable by as many people as possible. So I would highly encourage you to look some of that up. Avoid reading directly from your slides. And I think what's really common, especially if this is your first presentation that you're presenting, if you go into PowerPoint, for example, I think in the bottom, see there's notes over here. You can click to add notes. You'll notice I didn't put any notes. I'm not using notes here. I've got an iPad with a couple other notes. But I don't put the notes here, but if it helps you to type notes here, you can save these. But don't put things that you're going to read during the presentation. Then during the presentation, when you're in presentation mode, the slides will appear on the monitor for the audience. Your monitor will have your notes on it with the slides. But don't read those. You should use those with a couple bullet points of things you want to talk about to make sure you don't forget them. And you want to focus what you're talking about in terms of a good narrative to tell your story and to focus on the key points and observations that you're making. And really just speak conversationally, speak just kind of naturally. Because if you kind of read that script, you kind of sound kind of monotonous and kind of like a robot, and then you're going to lose your audience real quick. They're going to be kind of, they're going to, not be very interested. So don't read directly from those slides or notes. The two most important parts of your presentation are the first part and the last part, the introduction and the conclusion. And so it's really important. You want to, if you start without any context, or your ending abruptly just fails to engage or leave a lasting impression, you're going to have lost your audience. So you want to focus on a good, clear introduction that introduces the relevance of your topic and the key points and the hypothesis. And you're going to want to conclude with a series of very succinct summary points, as well as some key implications of that research in the very end. So I think that's important. Don't ignore the time constraints. The best way to do this is to practice. Sorry about that. So practice your talk to ensure that you're using your time appropriately. And so make sure you go through your talk without going over, right? And make sure you prepare for your questions ahead of time. You could actually use AI to help with this, or use your peers. You could kind of ask the AI, what are some potential questions that could be asked about this paper if I'm presenting it? Make sure you could go through the strengths and weaknesses, as well as the key implications and the main points of that paper. If you're not prepared for questions, this kind of destroys your creativity and your readiness, and you're kind of done, right? So make sure you prepare for that. You also want to speak just natural speech. Don't speak in a monotone. If you're in a flat, monotonous tone, that kind of feels dull. You sound like kind of a robot. If you use variations in tone, pace, and emphasis, that keeps your audience engaged, right? And the way to practice the way to do this is just by practice, right? Because Michael Jordan did not become a star basketball player and an Olympic gold medal winner and an NBA champion by not practicing. The amount of times he practiced that basketball, he practiced all the time, and he got very good at what he's doing. So practice will help you deliver a much more polished presentation, and it'll sound a lot better overall, right? And so lastly, your last presentation slide will be an acknowledgement slide where you thank everyone that contributed to the success of your talk, right? Now, in a literature seminar in graduate school, you probably won't have sources of financial assistance, but if you're presenting at a national meeting, or if you're presenting a thesis talk, you were probably supported maybe by an NSF grant or an NIH grant, or other sources, you will want to acknowledge those sources of financial assistance. You should acknowledge any faculty, especially your advisor or your committee and other faculty that you may have collaborated with. Acknowledge any other graduate students you work with. Please don't forget to acknowledge the department secretary. They're very hardworking people. They're often underpaid, and they keep your entire department and your college running. So make sure you show your appreciation for those secretaries, the administrative assistants, if you will, right? They're very important. And of course, you want to thank your audience for listening and for participating in the success of your talk. So that's also important. And with that, I want to thank you for listening. And if you're interested in this content and you like that, please hit the subscribe button. That way you can go back for more. There's a little bell icon. That way you're kind of notified when there's new information, new topics posted in the channel. You can also hit the little thumbs up button. You can like the comment if you like this. And if you have any questions, leave those in the comments below. So that's also there for you. So I want to thank you for listening, and I appreciate it. I'll see you again. Thank you for watching Biochemistry Unfolded, from atoms to algorithms. If you enjoyed this content, please subscribe to this channel, and we will keep you informed of future episodes. Thank you.